impulse. So impulse, one more very important concept. In many cases we are going to discuss about this one. What exactly impulse is? In many cases we have seen a large amount of force will act on the short interval of time. Okay, so the large amount of force act on a body for a very short interval of time. Okay, so for example, when ball comes, when you are playing a cricket, so when ball comes, the batsman will hit the ball. Okay, with a high speed, or with a lot of force. So this force is acting on the ball for a very short interval of time. Okay. So what will be the effect of that kind of forces? Usually we know when the force acts on the body, acceleration will change, and so many things. For that you have to calculate what your force, and then you can find the acceleration, all those things. But here a very large amount of force is acting for a very short interval of time. So how we can study this kind of forces? It's not possible to measure them at the same instant of time. So what will be the effect of that one? Okay, so this kind of force, a large force acting for a short interval of time, short interval of time is called impulsive force. This is what impulsive force. When a large force acts on any object for a very short interval of time, that kind of force is called as what? That is called as impulsive force. Okay. So because of this large force for a short interval of time, what is happening here? The direction of ball is changing, or the momentum of ball is changing, or the force, the acceleration of the ball is changing. So some effect is happening because of this large force for short interval of time. So that large force for short interval of time is what? Impulsive force. Because of impulsive force, some effect is happening on this whole system. So that effect of impulsive force is called impulse. Getting the point? Effect of impulsive force is called as impulse. Okay, so a large force acting on for a short interval of time is called impulsive force. The effect of impulsive force is called as what? Impulse. Okay, what exactly impulse and how we can define mathematically, that we will see later. But how we can measure this effect? So suppose when cricket ball comes and batsman hit that one, so it is going in this direction. Okay, so mainly what is changing over here? So it was coming in this direction, now it is going in this direction. Direction is changing. If direction is changing, obviously velocity will change. So many things will change. So to study that one, what exactly impulse we can give by the force into time. Okay, so the larger force for a short interval of time, that is what we call it as the impulse. Okay, so impulse is what we can give. The impulse equals to, I can write into delta t. So you can define impulse like this also. The product of a large force acting for a short interval of time, or product of the force and time. So I can denote this by J or Jacob. It is a vector quantity. So what I can write is, it is a product of average force and time interval for which force acts on the body. Okay, so this definition also you can give. Either you can go with this definition, or you can go with it is a product of average force and time interval for which the force acting on the body or on the system. Okay, so here, so what we can write? We can write as J equals to F into delta T. But when you consider this particular example, or you can take any example, here force is acting, a large force is acting for a very short interval of time. Okay, for a very short interval of time, it is very difficult to measure both force and time at a time. Okay, so it is acting, it is happening in a very fraction of second, fraction of time. Then it's difficult to find at that moment how much force is acting, how much time it has taken. Okay, so practically calculating the impulse is difficult if we go with this formula. But I can just write this as impulse. I can write it as J equals to force into delta T is there. Okay, so what is force? Force is mass into acceleration into delta T. Okay, so what is the acceleration? Acceleration is nothing but what? Change in velocity divided by time. Okay, so delta T. See here, this delta T I will get cancelled. So mass into delta V. Okay, so what is this delta V? It is nothing but change in velocity. So change in velocity I will write it as V2 minus V1. Yes or no? Change in velocity, final velocity minus initial velocity, or I can write it as final velocity minus initial velocity. So this will become what? See, we can call it as mass into final velocity minus mass into initial velocity. Okay, what is this one? Mass into final velocity is what? It is nothing but m into v is nothing but what? Your momentum, final momentum minus initial momentum. Okay, so J equals to, it is nothing but change in momentum. So impulse is equals to change in momentum. Okay, so if you calculate what is the change in momentum, you can easily give the answer for the impulse. If you know the impulse, you can easily give the answer for what is a force. If you know the time, you can give the answer for force, or if you know the force, you can give the time. But to calculate impulse, the change in momentum is that you can easily calculate, because you know with what velocity is coming and you can calculate with what velocity is going. So mass is going to constant, so you can easily calculate what is that mvf minus mvi. Because velocities you can easily calculate. That is what for every ball in cricket match we can see with what speed he is throwing the ball. Okay, so remember, very important, impulse is equals to change in momentum. Okay, so what we got? Impulse we got it as impulse equals to change in momentum. Okay, so impulse equals to change in momentum, or you can write it as J cap equals to F into delta T. Okay, so but it is not possible to calculate these two, so we are using change in momentum. So suppose a body is moving here with say with a velocity of with the initial velocity of, say it is moving with some 10 meter per second. So it is of, say, some 2 kg of mass. Okay, some force act here for a very short interval of time, so that made it to move with a velocity of say some 20 meter per second. Okay, so this 20 meter per second is coming because of what? Because of this impulse. This force is acting for a short interval of time. Okay, so if this much is there, we can calculate what is the impulse. So impulse is what? It is the momentum, final momentum minus initial momentum. Okay, what is the final momentum? Final momentum means mass into velocity. Mass is 2 kg, velocity is 20. So initial mass into velocity, that is what 2 kg into 10. Okay, so this is what mv minus m into u, or you can take m outside, so v minus u. So m is 2. What is v? V is 20. So 20 minus 10. So this will become 2 into 10, so 20. Okay, so what unit we can do for the impulse? Impulse is what? Force force is what, Newton, and time is what, second. Okay, Newton second you can give, or if you want to go with some kg meter per second square, then time second, it will become kg meter second, or simply it is nothing but the unit of momentum only. Okay, so Newton second we can write, or simply you can write the unit of your what, momentum. Okay, because it is nothing but change in momentum. If I look at another problem from your NCERT, so page number 96 and example number 5.4. So if I take example number 5.4, so what they are saying, a batsman hits back a ball straight in the direction of bowler without changing its initial speed. See here, a ball is coming with the initial speed of 12 meter per second. Okay, so a batsman hit it. Without changing its speed towards the bowler. Okay, towards the bowler means he is not changing its direction. It is coming in this direction. So he is hitting the ball from here. Okay, so this is what they are giving. So mass of ball is 0.15 kg. So mass of ball is 0.15 kg. Okay. So then what they have given is determine the impulse imparted to the ball. Okay. So what is the impulse imparted to the ball? Because of this bat, some impulse will be imparted to the ball. So ball is coming in this direction. Okay. So now impulse is equals to what? Impulse is equals to change in momentum. Okay. So to calculate change in momentum, so what you can write? You can write it as mv minus m into u, final velocity minus initial velocity. What is the mass? Mass is 0.15. Velocity. See here, you have to take either any one velocity, negative or here. Okay. Suppose if you take this as positive, you have to take this negative, or if you take another positive, you have to take one more as a negative. Okay. So here velocity is in this direction. I will take velocity 12 meter per second only, because without changing its initial velocity, I say, so this is what, 12 minus mass is 0.15. What is the u? U is this one. This is, but direction is opposite, so you have to take negative. So this is what going to be, say, minus 12. So you can take 0.15 outside, so this will become 12 minus plus 12. Okay, so 0.15 into 24. Okay, 24 into 0.15. So what you can get, you can what approximately they given it as some 3.4, 3.6 Newton second. Okay, so that is what they are given. So this is how we can calculate, or simply you can multiply separately, then add it. That is all your wish, but we should not forget to mention the sign. That is what very important. So now, so this you have to remember. This you have to remember. If it is going and returning to the same. Suppose if you throw a ball. If suppose there is a ball. Okay. Suppose if you throw a ball, its velocity is in this direction. So while coming back, its velocity will be what? Its velocity will be v. So that is why the impulse what given by the ball to the ball is what? You can take this as negative or this as negative. Whatever I will make v as negative. So m minus v minus of m into u. Okay. So minus mv minus mu. Your answer will come what? Your answer will come in negative. That means the wall is giving the force in opposite direction, in this direction. Okay, so opposite to the direction of the initial direction of the ball. Okay, so it will help to solve this kind of problems. So that will more problems will see it. So let me take another example from your NCERT textbook, example number 5.5. Okay, so here they are given two billiard balls. So this is what wall. Okay, so one ball will come and hit it, and it is going back. Okay, so this is what the ball. Its mass they have given it as m. So similarly, in another case, the ball is coming with some angle. So again, this is what going to be your wall, and it will go in this direction. Okay, and what it is making angle? It is making angle of 30 degree here. So if that is 30 degree, this is also going to be 30 degree. What they are asking is the first question, what is the same qualities, mass m only. What is the direction of applied force? This ball will apply some force, or it will apply force for a very short interval of time. In what direction? It doesn't mean that it is applying in this direction, this is applying in this direction. No, because it is coming here means the direction of applied force may be different. If it is change, if it is applying force in this way, then there may be a change in the some structure of the wall or something. Okay, so there may be a different directions, but it is not possible to find the direction of force applied by this wall on the wall directly. But we can go in opposite direction. We can find what is the what is the force applied by the wall on the ball. Okay, so if you find that one, equal and opposite force from the Newton's third law, we can say what is the direction of force applied by the ball on the ball. Okay, so now they are asking direction of force on wall by ball. Okay, on wall by the ball. Okay, so I will take first case. In first case, it is coming with some initial velocity. See here. However, whenever it comes, we have to divide that into its components. Okay, this is what the y component. So this is what x component. This is what y component. Okay. Suppose its initial momentum is p. What is its component along x-axis? I will take it as px. Okay. So momentum along px is what? Its mass is m. Say velocity you can take u. Initial velocity you can take u. That will be what? M into u. What is the velocity along y? It is not having the some angle. It is along the x only. Along y is what? It is going to be 0. So py is what? 0. Okay. So this is what initial. What is the final momentum? Final momentum is after hitting the wall. I will take that as p dash. Okay. So p dash along the x-axis is what? I will take it as minus mu, because direction is changing. Let me take it as minus. Okay. Here velocity is u. Here velocity is minus u. So it will become minus pu. What about the y direction? That is what? That is going to be 0. So don't need to study about the change in momentum of along the y-axis, because both are 0. We can take this one. Change in momentum is equals to what? Is equals to final momentum minus initial momentum. That is what final momentum is minus m into u, minus of initial momentum is m into u. So this will become minus 2mu. Okay. So change in momentum is equals to what? Change in momentum is equals to what? It is equals to what? The impulse. Impulse is what? Force into delta t. That is what we are getting, minus 2mu. So what is the direction of this force? Direction of force is minus 2mu, means it is along this direction. Okay. So the direction of impulse, change in impulse or force applied by the wall on this impulse is what? This change in momentum is nothing but what? It is an impulse. It is nothing but an impulse. So this is direction of impulse. Impulse will be given by this wall, not by the ball. So this is what? Direction of impulsive force or impulse. If this is in this direction, according to your Newton's law, what is the force applied by ball on the wall? Obviously it is equal and opposite to the direction of impulsive force. So this is what? Force on wall by ball. Okay. So it is what? It is normally on the wall along the positive x-axis. Okay. So acting normally on wall along positive x-axis. Positive x-axis. What is this? This is the force acted on the wall by the ball. Okay. So similarly, if I take this one, again here you have to take what? Initial momentum p. So here you can divide it. Here you can divide it in a different directions. Okay. So what is the px and what is the py? Like that we have to divide it. If I take x and y components here, if I take x and y components over here, this is what y and this is what x. So x component will be in this direction, and y component will be in this direction. So what is the change in momentum? What is the change in momentum here? Px along px is this angle is 30 degree. So mv cos 30. Here it is. Py is not mv, it is mu sin 30. Okay, mu sin 30. But remember, it is in downward direction, so you have to take negative. If it is upward, y will be positive, because this is what y is positive here and y is negative. Downward is negative, so we have to take negative. So what you can write here, initial momentum px is equals to mu cos 30 and py is equals to minus mu sin 30. Okay. So similarly, what about the here after hitting the voltage, it will come in this direction. So here also you can divide it in two directions. Okay. So what is this? This is x and y. So x is going to be negative now. It is going to be here. So x will be here, and this is 30 degrees. This is going to be 30. So this is what mu cos 30, but negative, because along the negative x-axis. Okay, because along the negative x-axis. So px dash is minus mu cos 30. What about py dash? Py dash is again it is in downward direction only. Again it is going to be in downward direction only. So that is what going to be minus mu sin 30. Okay. So now impulse, we can write impulse along x-axis. X component of impulse. So what is that? So px dash minus px, so that is minus mu cos 30 minus of mu cos 30, that is what, minus 2 mu cos 30. Okay, so this is what impulse, change in momentum for the x. What about y component? If you write y component of impulse. Okay, so py dash minus py, so that is what py dash is minus mu sin 30 and minus of again minus mu sin 30. Okay, so minus will become plus, so this will become 0. That means no force will be acted along the wall, means parallel to the wall. Okay, so the wall is acting the force. How much force is acting? It is minus 2 mu, because impulse is equals to what? Minus 2 mu cos 30. Okay, so it is negative. That means wall is acting force in this direction normally. Okay, so if wall is acting, impulse is in this direction, that is force into delta T is in this direction, means this is the force by wall on ball. But what we want on wall by the ball. Okay, so what we want by ball on wall. Obviously it is equal and opposite, so it is along the positive x-axis. Okay, so direction is normally on wall along positive x-axis. Okay, so you can just go through the it is solved as an example in your NCERT. You will understand over there. So this is what the how we can find the direction of force applied by the moving object on the wall or something. So similarly, they extend the question. What is second question of that is magnitude of impulse imparted to the balls by the wall. They are asking the ratio of magnitudes of impulses imparted to the ball by the wall. Okay, so they are asking ratio of these two. So in second question they are asking ratio of these two, that is what px, sorry, change in momentum delta px. So ratio is equals to, what is that, px delta px divided by delta px2 px1. Okay, so first case and second case. So probably don't get confused, so directly I will write what is that, minus 2 mu, and this is what minus 2 mu cos 30. Okay, so these all things can get cancelled, 8 and 8 will get cancelled. 1 divided by cos 30. Cos 30 means what? Cos 30 means root 3 by 2. So that is what going to be 2 by root 3. Okay, so this is what the ratio of the impulses imparted by the wall in first case and second case. Okay, so that is approximately 1.2. So one more interesting example based on impulse only. Suppose a ball in this direction with a velocity say 5 meter per second. Okay, so 5 meter per second. So mass of ball you can take it as root 2. Now what will happen? The batsman will just change its direction. So we say it will go in this direction. Okay. So that means there they will ask what is the impulse? Impulse imparted to ball by the bat. Okay. So now see here we have to first find the impulse in both direction. Okay. So with what angle you will change direction? You will change the direction of direction of ball by some 45 degree. Okay. So they will give the angle and they will give these two quantities. Okay. So mass is given. Mass is root 2. So initial velocity u is what? U is 5 meter per second. And what is the angle? Theta is 45. Without changing its speed, you can just changing the direction. Okay. So this is what 5 meter per second only. V is also 5 meters per second. U is also 5 meter per second. But here we have to find the component. If this is 45, this is also 45. Now you take components of u. Ux is what? 5. What about uy? Uy is 0. There is no vertical components. Okay. So initial momentum is what? Ux is mass m into u. That is what mass is what? Mass is root 2. So root 2 into 5. Okay. So root 2 into 5. What about uy? Uy, sorry. It is not ux, it is px, momentum. So px is mu, and what is py? Py is going to be 0. Okay. So this is what momentum along the x. Okay. So we will see final momentum. Final momentum is again you have to take px dash. What is px dash? Px is m into u. That is no problem. But you have to take its component. So its component will become what? This is what m into u. Its component will become here mu cos theta, cos 45. Here it will become mu sin 45. This is what py and this is what px. Okay. So px dash and py dash, final momentums. Okay. So px dash is what? Px dash is mu cos 45. That means mass is root 2, velocity is 5, cos 45 is 1 by root 2. Root 2 will get cancelled. This is what? 5. Similarly, py dash is mu sin 45. So again root 2 into 5, sin 45 is what? Again 1 by root 2. So this one will get cancelled. So that is also what? 5. Okay. So now what is the change in momentum? What is the change in momentum? So change in momentum. Okay. So along x, delta px is what? Px dash minus px. So that is what? 5 minus root 2 times 5. Okay. So root 2 5. So take 5 common. So this will become what? 5 will be common. So 1 minus root 2. So similarly here delta py is what? It is 5 minus, that is py dash minus py. So 5 minus 0, this will be 5. Okay. So you got impulse along x. Impulse along x is what? 5 1 minus root 2. 1 minus of root 2, what you can get? Root 2 is approximately some 1.4. So 1 minus 1.41. 5 1 minus 1.41 means it is 5 into 0.4. So 5 into 0.4 means what? It is going to be 2 and this is going to be 5. This is what? J1. So they are asking you total impulse. You cannot simply give the components. So how you can find the resultant? Resultant is jx square plus jy square. So jx square is what? It is 2 the square plus 5 the square. So 2 the square is 4, 5 the square is 25. So this will become what? 29. This is what the impulse transfer from back to the ball. Okay, so like this they may give the different angles or different velocities, so you should be able to find the resultant also. Okay.